In modern warfare, invisibility is the ultimate advantage. But physics has a strict set of rules that makes hiding nearly impossible. Welcome to the radar equation. Stealth isn't magic. It doesn't make an aircraft disappear from reality. Instead, it is an engineering game of manipulating how energy interacts with the airframe, delaying detection until it's too late. Let's build the architecture. On the left, our transmitter P sub T, blasting high-power electromagnetic energy. On the right, our target. The most critical variable here is the range, or the physical distance between the hunter and the hunted. We don't waste energy broadcasting in all directions like a light bulb. Instead, we focus it like a spotlight. This focusing ability is called antenna gain, or simply G. It directs our massive power output exactly where we need it to go. Here is the physical challenge. As the pulse travels out, it spreads spherically, losing density. When it hits the target, it reflects, becoming a new source, and spreads spherically again on the return trip. This two-way journey is devastating to signal strength. This is sigma, the radar cross-section. A flat truck reflects energy directly back to the source. But a stealth design uses geometry to deflect energy away. To the radar, a massive bomber can look like a small bird. Let's visualize the attenuation. One-way communication, like a radio, drops by 1 over r squared. But look at the radar return in pink. It plummets by 1 over r to the 4th power. The energy loss is exponential and catastrophic as distance increases. The sky isn't silent, it's filled with background noise. For a radar to see, the returning echo must be stronger than this noise floor. If the signal drops below this chaotic threshold, the target becomes effectively invisible. This brings us to the full radar equation. We want high power P sub T and high gain G. But look at the denominator. Distance isn't just squared, it is raised to the 4th power. This is the governing law of radar physics. How brutal is the 4th power? If you double the distance to a target, you don't get half the signal, you get 1/16. A small increase in range costs a massive amount of energy. This dictates tactical reality. A standard fighter is detected hundreds of miles away. A stealth aircraft reduces sigma so drastically that the radar can't distinguish it from noise until it is dangerously close. To summarize, energy spreads twice, signal strength dies by the 4th power of distance, and stealth works by starving the radar of a return reflection. Thanks for watching.